In our continuing review, this is chapter 5 and 6, and chapter 5 was about characteristics of polynomials. Just a reminder, what the heck is a polynomial? Well, a polynomial is like when you have usually lots of terms, like 3x to the third plus 2x squared plus x plus 1. And you have to know things like, oh, this is positive in front, and so the right end goes up. Do you remember that deal? That's going to be on the test for sure, on the final. And then the fact that this is odd degree means that they have to be different on both ends. So if the right end is up because the lead term's positive, then the other one must be down. All right, then there was limits to describe that. So like if I knew this one is going up on the right, has a y-intercept of 1, and then it has to be going down on the left because this is telling me the ends are opposite from each other. See all of those things that I know from this? Do you know those things? The thing in the front, this is called the degree. The fact that that's opposite tells me ends are opposite directions. This is the y-intercept. Do you remember all that stuff? All right, so this is what polynomials are like again. So what if they just give you 2 points? Remember that this, right underneath it, is just 4 comma negative 3 and 6 comma 10. Now it says linear. You got to remember that means straight line. So this is chapter 5. If you can get that out as you find your seat, that'd be good. So this means straight line through those. Here's an equation. Again, it'd be so smart for you to look through this right before you took the final, because I bet you some of you have forgotten this one. And this is what you need to be able to make a equation of a line through those 2 points. Y minus y1 equals m times x minus x1. Now I'm going to highlight a couple spots that are the key spots. That and that is where the point goes. So like, here's my x and y. The y goes where the y is. The x goes where the x is. And then you got to remember how to find slope. The slope would be 10 minus negative 3. See where I got that? Over 6 minus 4. That's your slope. So many little things to remember in math, but this honestly does come up. I've seen it on the ACT before. I have seen it on my top 20. I have seen it in math classes above this one. So bottom line, knowing this equation, I was told by a calc teacher that they use this y minus y sub 1 thing. They use that more than any other form of an equation, because they tons of times have a point and they know the slope, and that's what this is good for, is if you know the point, it goes there, and the slope goes here. So finishing it off, this would be 13 over 6 minus 4 is 2. 13 over 2 would go right there, and your point just drops in there and there. And that came from here and here. And again, we have a key, so you can always look this up. But there's a quick reminder of how you do it. What about the quadratic kind? Take some notes on this. This is your form for a quadratic where you know the vertex. And this goes right there. And that goes at the end. And now I know my vertex is in the right spot in my vertex form, but I don't know A. Since I don't know A, I can solve for A by sticking in this x goes there, and this y goes there. And all of a sudden, you just only have an equation that has A in it. Do you get, then you could solve for A? So this would end up being 51 equals A times the x of that came from here. This is 5 minus 1 parentheses squared plus 3. And if you can't solve that for A, I can't really help you. I mean, this is pre-calc. You're supposed to be able to solve equations. So I'm sure you could solve it for A. Once you got it, your final answer is this again, except you write the A in. So if A came out to like 4, you put the 4 in for A. All right, again, you can always check the answer key for this to make sure you're doing it right. And I got to keep moving, and I got to move fast. All right, vertex and axis of symmetry all come down to this equation. It's the shortest equation that you have to memorize, but I swear it's the most forgotten. Can you tell me the right equation to use for both the vertex and the axis of symmetry? Anybody? Claire, give it a shot. Yes, that's the one. X equals negative b over 2a. And remember, the vertex will actually be negative b over 2a goes here. And f of negative b over 2a is the rest of the vertex. So the vertex is that. The axis of symmetry is that. Again, I'm hoping that you are going to go on, do this problem, check it, make sure you're doing it right. But for right now, my job is to just go through all 6 pages of this stuff and give you some hints and help. All right. The next page has a million equations on it, but it doesn't really ask us like what to do with it. So I can tell you the things that we could ask you about all of these equations. Number one is, of course, can you factor them? If you can factor them, if you can factor it, you should. Okay, and that tells you the x-intercepts. Another thing you should be able to do with them is find the vertex of them. And that's with negative b over 2a. All right, so I'd say the trickiest ones to factor are the ones that are weird. Like if you're asked to factor that, a lot of kids are like, well, there's no third number, so I don't know what to do. What do you do? What's your first step on this? Factor x out. Very good. Actually, there's more than just x, though. 5 out. 5x comes out, and then you do the rest. Okay, how about this one? This one's weird because, Trent, what's weird about it? Good, so factor that out. Negative 1. Tell me what we'd have. Plus 11x plus 10. Good, and then I bet it factors, and it does. And once you got it factored, you've got the x-intercepts, the roots, the zeros, the solutions. If they really just wanted the vertex, well, then you'd do negative b over 2a, so that'd be 11 over 2 times negative 1. That'd be a little bit of a weird start to your vertex, so probably isn't wanting the vertex. These are just factoring problems. How about this kind of factoring? There's a 3 in everything. You got to remember to factor out the 3. And don't even try to do the next set of factoring until you got the 3 factored out. That's called the GCF. All right. Next page. Even more factoring. Do you get the feeling that we want you to be able to factor on the final? Yeah, it's all over the place. All over the final. You got to factor. So hopefully you've learned that by now. If you haven't, this is your chance. Come up and ask me questions. All right, the next chapter here is called Higher Order Polynomials. Now find that one. It's chapter 6. If you haven't already opened chapter 6, open it now. I'm going to give you some hints and help for this one. Okay, so this is the part where we're talking about limits. So if I needed to know the limit for this thing, I'd need to know a sketch. So seriously, every single time, make a little sketch of it. And what do I mean by sketch? Like a complicated graph? No, just like the y-intercept's negative 4, so I put a dot there. Everybody do that, put a dot at negative 4. This is positive, so then I know it's going up on the right. That's odd, so I know it's going down on the left. Now for limits, I really don't need to know exactly what this thing looks like. I can totally fake this stuff in the middle. As long as it goes through that y-intercept and it's going down here and up there, that's all I really need to know to be able to write a limit. Then, if I was writing the limit for this thing, the left limit, that's this side over here, of course, you go lim of the function, and you always do x approaching, that's how you say that, x is approaching, and then you got to think about where you are and what it's approaching. This is where you're going. That means x is going this way, so x is going towards the negatives. And then the y value goes over here. When you get way to the left, your x keeps going to negative infinity, the y would be at negative infinity. The right-hand limit, which is this one, would be the lim of the function as x approaches, well, x is going this way, so x is going towards positive infinity. The y value is going up like this, so then it's positive infinity. Will these ever be anything other than infinities? Yeah, they can be, but almost always, if you're on the ends, the left end or the right end, you're going to go into negative and positive infinity. And then if the function just goes up forever, then it's infinities. The only time it wouldn't be infinity is if it like leveled off. So if you had a graph that was like this, where there was an asymptote here, and the graph like levels off, then that doesn't go up forever. It's got like a roof, it's got a ceiling on it of, let's say, 10. Well, then the limit of this one, when you go way to the right, as x goes to infinity, the limit would be 10, because that's the highest it can go. All right, most of yours are infinities, though, because they usually just keep going up or keep going down. All right, so what was the first step on this? You got to sketch it. Everybody try numbers for part C. You might be like, there's no number at the end, so I don't know what the y-intercept is. There is a number. It's 0. So it goes through 0. Ethan, is the right end going to go up or down based on what you see here? Down on the right. And then the left end? Well, look at that odd number there. Now you tell me. Up or down? Up, because it's going the opposite direction. Odd means opposite. Since the degree is odd, they must be going opposite directions. Now, what you do in between, I don't care. Doesn't really matter to me. Because when you're writing a limit, all we care about is this and that. Okay, good enough on that. One thing that people get confused on is they're like, well, I don't know the lead term. Look at letter E as in elephant. Everybody get to E as in elephant. The lead term, that's a critical thing to be able to do. That's this and this and this and that. All get put together, and it's negative 2 x to the, careful, what is it? Somebody say it that's got confidence. 3 is correct. 1 for this, and that being squared means 2 for that. So then, that's all I really need, because then I know that the right end goes down, left end goes opposite direction than that. All right, so that's called the lead term. It has the leading coefficient on it, the degree on it, and then it says y-intercept. Everybody underline y-intercept and write x equals 0. If you ever want the y-intercept and it's not just the thing at the end, you got to stick in x equals 0. If x equals 0 here, 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 and here. If you're smart, though, you realize 0 times anything, in this case, it's going to come out to 0. So look, y equals 0. If x equals 0, but when you're at the y-intercept, we're trying to figure out y. Y equals, and again, no reason to like even stress about what negative 2 squared is and all that. You got a 0 times at the beginning. The y must also be 0. So this one's at 0, 0. The y-intercept is where x is 0. So here's another one where you have one that's a little more interesting, because y-intercept is where x is 0. You actually have to compute this one. It's not just 0. That turns into -1 squared. That's -1 to the 4th. And this one's 5 squared. So that y-intercept will be more interesting. It's not just 0 all the time. The only reason it was 0 on this one is because it had a 0 times at the very beginning. So then when you do 0 times anything, you get y equals 0. Okay, so there's some hints for that page. And our last page for the day. Write the equation that's got these zeros. Equations always have y equals at the beginning. Or f of x, the same thing. So start with that. And then, for each of these numbers, I got to make a little factor. So, in this case, hello, sir. I'll pause for just a second. Okay, so I'm making the rest of this thing by just making little parentheses for each one. And then this one becomes x plus 6. And then this last one becomes x minus 4. And that's all you got to do. What if there's 2 4s? Well, then you literally could just write x minus 4 twice. But what would be a little smarter than that? If it's really x minus 4 and another x minus 4, you could put them together and say squared, couldn't you? All right. On this one, they want us to graph this thing. And these are the kind where you're like, oh, it bounces here, and it like has an inflection point there, and it does this. Okay, so let's talk through this kind. We can make the little sketches based on the info they gave us. All right, so they told us it goes through 1 by saying that 1 is a 0. It's an x-intercept. It's a root. X equals 1 is important, so I put a dot there. And what's it doing there? I'm going to call INF. That stands for inflection point. That means that it's doing one of these deals where it changes the rate at which it's going. Like it was rising at a decreasing rate, and now it's rising at an increasing rate. That's called an inflection point. As long as you pass through it, I'm going to be okay with it. If you bounce, though, that'd be wrong, because this one is a bounce. It's bouncing at -2. So how do I do that? Well, I got to figure out my ends first, though. I don't even know which way they go until I know the ends. So once again, that lead term is huge. Would everybody please figure out the lead term for this? It's like 2x to the 5th or something like that. Figure out the lead term. I'm going to use the dice of destiny to call on somebody, so I'll be ready. We're finding the lead term. Row 3, last person, Dominic, that's you. X to the 3rd? No, because, oh, what'd you say? X to the 5th is correct. Thank you, I just couldn't hear you. X to the 5th. You take this, and that, and that. So you get x to the 5th. There was no negatives on those x's. There was a negative on the 1, but there wasn't a negative on the x's. So that means it's going up on the right, because this is positive, and that's odd, so it must be going down on the left. So it's got to be bouncing here, boing, and it's got to do one of those cool inflection point things there, because it's a degree 3. In this year in precalc, we really didn't talk about that much. As long as you make it go through the x-axis there, you'd be okay. You just better not let it bounce. Okay, so there's your sketch. One last thing, if you really wanted to be getting full credit, it says your y-intercept has to be right. Dang, how do you do that again? Y-intercept. Row 5, first person, Alex, that's you. How do you get y-intercept again?
If it's like x minus 1/3, I would like write it out 3 times kind of, and then you can multiply it by that.
You can, but there's a simpler way. The y-intercept is just where x equals 0. So I'm putting a 0 here and here. That's it. So now y equals all of that. and let's do it. What's negative 1 to the third? Alex, you got that? Negative 1 to the third? Yep, it's just negative 1. And then 2 squared? Now multiply them. Negative 4. Yep. This was negative 1. This was 4. Negative 1 times 4, negative 4. Okay, so it asked me to label the y-intercept, so there it is, and so I should say that's negative 4 right there. A lot of people are going to forget that on the test, and since it says you got to have the y-intercept there, well, then you have to say what it is. And how do you get it again? You stick in x is 0 and you figure it out. So if I want the y-intercept on this, it's super easy. I stick in 0, and I go 1 times negative 2 squared, which is 4, so that one's at 4. So the y-intercept's at 4. See how quick that is? Y-intercept is where x is 0. So I'm going to write it down because I know some of you will write it down if I do. And if you don't know how to find y-intercept, there goes another couple questions. All right. On to this page. It's just more complicated of the same thing. So again, if I was going to do letter F here, I'd start with putting a negative 1, a dot at negative 1. That's backwards. But if I write 2 minus x has to equal 0, I can figure out what x has to be. Subtracting 2, negative x equals negative 2, so x must equal 2. And if I check it, I just stick it back in and I go, if I put in a 2, yeah, it works, x is 2. So here's x is 2. The first one here was at negative 1, and then this one is at 4. Sorry, I'm going to pause for a second. Okay, so it's going to touch those 3 spots, negative 1, 2, and 4. I need that lead term. Do you see how often I go get this? Every time, pretty much. I got to go get the lead term. X squared, and then this is a negative x, careful with that, to the third. So that's x to the 5th, but it's negative. And then there's one more x. Negative x to the 6th. You get how I got that? I'm going to highlight everything I used. I used that to the that to the that, and that. Excellent. Thank you very much. And so now I've got negative x, of course, to the 6th. I'm double checking myself. 3, 4, 5, 6. Yep, that's right. So then if it's negative, that means it's going down on this end. And it's to the 6th, which means it's got to be going down on this end also. So as I draw my final line, it'll go, and I got to see where it bounces. That's the only bounce right there. I'm going to put a B for bounce. The other one, it just needs to pass through them. So pass through this one, pass through that one, bounce off of that one, and look at that. It worked. Okay, this is for sure on the final. Now, your final is, we have decided, going to be Marzano graded, and that means that it's easier to get a good grade. It's the same way we've been grading all your other tests. We were contemplating it to just doing a regular, like count up how many right you had and how many wrong you had, but then that's a lot different than how we did it all semester. So we decided it is going to be Marzano style, which means there's hard problems. But remember, if you can get 75% of the easy ones and 75% of the hard ones, you've got an A. There's not many finals like that where you can get 75 on the easy part and 75 on the hard part and still get an A. All right, so that should give you some comfort for your final, that you can get a few wrong and be fine. All right, so if you look at this final review and you're like, oh my gosh, I'm going to get everything, you're not going to get everything wrong. You're going to get a few things wrong, and that's okay. As long as you don't just give up and go, holy crap, there's so many things to remember, but I can't possibly do it all. Well, then maybe you'll only get 50% right, and that's not going to be a great grade. 75% right, it's going to be a great grade. All right, and that's all we have for today. There'll be one more day like this tomorrow where we cover a lot of stuff.